Today's video is going to be on how to insert a node. I am going to explain it very clearly in a pictorial manner. See, the singly linked list, as you people all know, it's a connection of memory units where A, B, C, D, they represent the data, and they are kept in different memory locations. They are linked from A to B, B to C, C to D, and everything is entered with a null. Now, how do you implement this? To implement this, you have to use some language. It could be C or C++ or Python, anything. So a C++ code looks very simple. It is you have to create a class called a node, actually, which looks like that, which has got two parts. One data part and the other is the address part. So when you create an object of such a class, then you can see the memory looks like that. It has got a data part here and there is an address part here which points to the next address. So next is the place where the address is there, data is the part where the data is there, and we use a concept called new to create an object from a class. For example, in order to create any object from a class is like a type, like an integer. Suppose you want to create a new integer location using a new pointer. You can see this is integer var, and I have the var is equal to 3000. There is a data, and if you want to create another integer location memory unit, you can simply create a pointer integer star ptr, and the ptr will be initialized with a new integer address. So you can say that the way the ptr address is initialized with the address of the var, and you can even create a pointer to pointer. You simply define integer star ptr. That means the first ptr will point to the another pointer which will point to this particular data. Now you can see that actually when you are initializing this ptr with the address of the var, you can see that the first line and second line star ptr everything prints the same. Now you see how do you use the new pointer with the class. The node is a simple data and an address. Address is a pointer called next. Now in order to create an object from class, a head object, next object, third objects, you can create through a pointer. Right now null is nothing but 0. So now you say head is equal to new node, it creates a new node in the name of head. Second is equal to new node means it creates a second pointer, a second object called of the type class node, and it points to the address second. Like that you can create multiple pointers like this. You can see on the screen there is a class, then you have created a class pointer and you created objects pointing to this address, 3 objects, head, second and third, and you can put in data by using this arrow mark. Head data 1, head next is equal to second. That means the first one is pointing to second, second is pointing to third, like that you can create. Now in order to transverse, now you have a head pointer which is pointing to the next, and again it is pointing to the third, like that. So it is all starting with the head. So that means you just give the head address, it will go on printing till null, till the end actually. So that even if you have 1 lakh such data memory connection units, it will go on printing if we use this print list head. Only head you have to give. So what is the head is nothing but the first address you are passing. You have to pass like this, node star n. So it will simply say while n not equal to null, that means null will come at the last. So till null it will go on incrementing to get all the data printed on the screen. This is a very simple function to print the entire linked list. Now just to practice whatever I talked so far, it's like a class node is there, and there is a function called print list which I explained some time before. In the main, you are creating 3 objects through pointers, and you are putting head data is equal to 1, second data is equal to 2, third is equal to 3, and head is pointing to the second, second is pointing to the third. How do you do that? You can say head node head arrow mark next second. That means the first address points to the second node. Second node points to the third node beginning. Third node is ending. That's end actually. If you print it out, it will print 1, 2, 3 like this. Now before we get in, a little more we can refresh about pointer to pointer if you try to understand it properly. See, look at only the main program. There is an integer where you have created integer star ptr, the pointer variable, then again star ptr, another pointer to pointer variable, and var contains the number 3000. So I have 3000, the pointer which points to the where, that is the address of var, is put into the pointer. Again the pointer which points to this var is now, this is a PTR. Now the PTR is also pointing, PTR is also another variable which is also the address of that variable is also put into PPTR, that is pointer to pointer. So now when you try to value VAR from main, it is 3000. Star PTR also it is pointing to the VAR, that means 3000. Star PTR also 3000. But when you suppose you call a function called a display PPTR, that means PPTR is a pointer to pointer, you pass it like this, so it is caught like this in integer star a. Inside this function you see that first it will star a, it will print the value of 3000. Next value of star PTR is nothing but an address which points to the pointer. So that's why it is showing an address. Next one is also the pointer to pointer, that is also an address. So this is a pictorial representation of pointer to pointer. Now as we said earlier, a new node when you created through the new operator, it creates an object called new node. It has got a data part and has got an address part, and data part can be represented by new node arrow mark data. Here it is new node arrow mark next. The entire thing is pointing to something called a new node, this address itself. Now head pointer is nothing but, it is like 0, null. So you create a null. If it was an integer, just to give an example, in the integer pointer, how you are making initializing the PTR is equal to 0, that is called integer star PTR is equal to null, that is 0. Same way you can take a node star head is equal to null, so that you can create a null class pointer pointing to null. Now inserting a new node between head and first node, it looks like that. You can see that there is a first node. It is pointing to a new node, that's called the first node. See that first node is the address which is kept here. That means it points here. Now it's all ready for, this is the initial condition. Let's say you are trying to create a new node which is pointing to the head node. So you have to configure it like this. That means this address of this has to be put inside. So that is the idea. How do you do that? You can see that the step one would be, you write in a line new underscore node next. If you first, let's say you created somehow a new node, this is all, and you say that next of that is equal to first node. That means you can see that, suppose there was already a head node which was already pointing to the first node, it additionally points to this new node also. So that means the diagram looks like what is drawn in the green lines. When you execute the first line, at the end of execution of the first line, it creates a pointer which points from here new node to the first node. So there was already a head pointer pointing to the earlier first node. So this is a new one, new baby which is coming in now. Now how do you go ahead? When you say a new node is equal to head, that means after executing this line, you see that a new pointer is created. The head is now pointing here. And earlier the green line you had created through the earlier line. So at the end of this execution, you see that now the head is pointing here instead of here. So that means this link is broken. So now it has created a new link via new node into the first node. So now creating first node from an empty linked list looks like that. This is the simple class. After that you have a pointer, which a new pointer object temp of type class node, and you have put in data here too and a null. And when you do this, all this program, temp is equal to a, that means you can see the pictorially it looks like that. You have created a head node which points to this first node. Now if you want to insert more and more nodes after the head, let's say the head is you can see this is the head which is pointing to the temp. You want to put in, let's say here 2, then again 4, then 6, like that. The code looks like that. You can see that earlier head you have created is equal to null, and after that you will create a temporary node called temporary node in new node. You will receive a data from the user 2. After that what you are going to do is, this temp next is now you initialize with the null, but the data, this is a temp, now you have made it equal to head. That means it is the pointer which is pointing from one to the next is already made. When I say insert 4 or insert 6, it comes into this function. See, insert 4 means 4 comes into this. It creates a new node, and what it does is actually that head is already a global variable that I have put into a temporary variable so that it won't get changed. And after that, this while line says that first look at the size of the linked list and go to the last of the linked list. And after that, you can simply receive a data from the user and you can put into this. Data can be updated. So this new node is created, and the new node is again now linked from temp1 to temp2. See, you can see all those things pictorially here. Here in the first part, you can see that the head node, the data is 2. It is pointing to the next. So you can go on inserting data like this at the end of the linked list using this program. You can closely look at this code. and you can understand how it is done. Now this is how it is creating. There is a head node, after it's pointing to 2, then it is going to 4. So you have different pointers, and these pointers are getting connected. See that this pointer temp 1 is getting connected to inside temp, the new temp 1 again going here. So that is why in the code actually every time it is creating a new temp 1. New temp 1 itself in a loop points to the next, like that it is going. Now inserting a new data, let's say not after the head, just before the head you want to insert it. Then you can create a function called push and give the address of that, and you say 11. So it is like you are creating a new node called E, which before head, and you altogether make the E as the new head, and you can the link can be established like this. So for this, now we will use the concept called pointer to pointer. When you use a pointer to pointer, you need not create a temporary node and such kind of stuff actually. So you can see the push, your head itself you are passing here a new data what is to be inserted. Suppose you say insert 6 or something, so head will come here and new data will come here. See, in C language it is you are creating a new node using this malloc function, and it returns a pointer. But in C++, you can simply say class new node is equal to new class. So C++ is more preferred for this. Now new node data is equal to new data. That means you have created the new data has gone into the new one which is created, and next is pointing to the next of the new node as the head now. Now if you see, you can see that when you say star head reference is equal to new node, this kind of new connections are established and the old head is removed, and this E becomes a new head. Same way, so you can see more clearly, you can go on pushing data like this, push 1, push 2, push 3. So it gets inserted exactly at the beginning. So the new head will be created. So the head will be, the old head will be replaced by the data. You can see that the data is being printed. This you can see through the compiler. You can execute it through any C++ compiler. If you want to insert at the end, actually like what is shown, E can be, suppose you want to insert at the end, and you go on adding at the end actually. So you can create a function called append, and head is passed and new data is coming. You have created a new node again. Now you can see that by executing all these lines, new node data is equal to new data has gone in, new data next is equal to null, and this line will go and search for the last node, and you will point that last node, last dot next is made as till that time you go. After that the new node is inserted at the end. Same way, you can insert a new node at a specific location, like you can see in this picture anywhere. So what you do is insert after, then head node is passed and the new data is passed. So that means you see that actually you can have a previous node and present node, it understands, and it exactly inserts at a particular location. So the function will be insert after second, let's say 11, it automatically does. So the point of the new node and the previous node swap, which means the previous node will point to the new node, whereas the new node will point to the next node. That way the traversal process will run correctly. You can understand this code a little more in detail going back to the video. And similarly, you can delete a node also. The process would be find the previous node, change the next of the previous node, and free memory for the node to be deleted. So the summary is, the data structure is a way to store and organize data efficiently in computer. A list is the abstract data type, is a mathematical and logical representation. Abstract data type means is a mathematical and logical representation. And arrays and linked lists and trees and graphs are the examples of abstract data types. And abstract data type doesn't have the implementation. Implementation is coming through C and C++ program. So need of the linked list is, static arrays have fixed size and you cannot increase it, and if you decrease it, there is a wastage of memory. That kind of problems are not there in linked list, and needs to copy all the old data if you need to create a new block. Otherwise, so that kind of issues are not there in linked list. Runtime dynamic memory allocation is possible only in linked list. It is not possible in static arrays. So there are two types of linked list: singly linked list, which is like is pointing one to another like this. Code is here. Same way you can have the last node pointing to the first, similar way, so that you can have doubly circular linked list. So at the end it will come back to the beginning, something like that. So there it will be a next node, next address also, previous address also. That's it. Thank you.